In this video, we'll design and build a boat with aluminum foil to test how well it floats and how much weight it can carry. For this demonstration, you will need a small tub or container with water, pre-cut sheets of aluminum foil, and a large amount of small weights. In this case, we are using paper clips, but you can also use pennies. Let's begin our activity by testing how well a single sheet of foil floats and how much weight it can hold. For now, we won't worry about shaping it into a boat. Let's start placing paper clips on top of the foil and watch how long it takes to sink. As you can see, it doesn't take very long before water starts coming in and the foil sinks. Now let's see if we can design a boat that stays afloat and carries more weight. We'll begin shaping our foil into different boat designs. Bend and fold the sheets to create the shape you want. Think about the width, height, and overall form of the boat and how that might affect sinking or tipping over. Wide shapes usually flow better because they displace more water. But you can also get creative. Your design doesn't need to look like a traditional boat. For example, here I'm making a flatter version and bending up the edges so water doesn't spill in. At first, it may not look like a normal boat, but it will still do the job of floating. After finishing your designs, it's time to test them. Gently place your boat into the tub of water. Does it float on its own? If it tips or sinks right away, reshape it until it stays afloat. Start adding weights a few at a time. Watch closely. Is the boat tipping or is water starting to come in? If it's still holding, keep adding the weights until it finally sinks. Be careful where you place the weights. Too many on one side can throw off the balance and cause it to sink faster. Thanks to its shape, size, and height, this boat can hold a large number of paper clips before sinking, but let's see if our other designs can do the same. This design is much wider, but it lacks depth. It can hold many paper clips if the weight is spread evenly, but it's more likely to sink if one side is heavier since the low edges let water rush in. When we test the other two designs, they don't stay afloat for long. Because they're smaller, it's harder to distribute the weight evenly and they tip over more quickly. How well a boat floats and how much weight it can carry depends on its size, shape, height, and weight distribution. All of these factors affect water displacement. The more water a boat displaces, the greater the buoyant force. In our test, we saw that flat, wider designs displayed more water and stayed afloat longer, while small, compact shapes sank more easily. Deeper designs also had a better chance of holding their load. This demonstration shows the same principles real marine engineers consider when designing ships: buoyancy, stability, and efficiency. Thanks for watching this video. For more activities and resources like this, visit the NOAA Office of Education website.